Welcome to the first video for Chapter 12. This video will be a review of temperature. Throughout this video, we will review Fahrenheit, Kelvin, and Celsius. Throughout our class, we will mostly use Celsius and Kelvin, but just want to make sure we remember all the different temperature systems. Temperature is the average internal energy of an object. We're going to look at this as thermal energy, but it's the average of all the energy in there and what level it's at. There are two main scales that are used worldwide. Fahrenheit scale is used throughout the United States, just like all the English system as opposed to the metric. Celsius is used pretty much everywhere else, including Europe and China and everywhere where we go. The United States way behind the ball once again. The boiling point of water at 1 atmosphere or sea level pressure is 100 degrees Celsius or 212 degrees Fahrenheit. The melting point or fusion point of water from solid to liquid is 0 degrees Celsius and 32 degrees Fahrenheit. Notice how there's a difference between the freezing and boiling point of 100 degrees on the Celsius scale and 180 degrees on the Fahrenheit scale. Throughout this class, we will pretty much exclusively use the Celsius scale. Hopefully, this should be a review. There are equations for how to convert between different scales further on in the lecture. The Kelvin scale comes from Lord Kelvin, who based his scale off of thermodynamics and pressure. And on the Kelvin scale, it's not measured in degrees, but 0 Kelvin is the lowest possible temperature, or absolute zero. And this here is when we consider that a molecule has 0 kinetic energy aside from its ground state energy. We will look more at thermodynamics when we look into chapter, I believe it's 14, and yes, 14 and 15. The conversion between Kelvin to Celsius is whatever the temperature is in Celsius plus 273.15, which is the measurement for absolute zero in Celsius. Thermometers can be made up of many different things. Most common thermometers are made up of a liquid that expands with some change in temperature, as we will see in a little bit in the next lecture, depending on the temperature, but most things will expand as the temperature increases. Electrical resistance changes with temperature, so there's another way to measure that change in temperature. Another way to also do it is to measure the infrared or thermal radiation that we have, that we see. We can't actually see it, but it is produced or emitted by all objects. So our eyes actually see electromagnetic radiation only in a very small spectrum, in the visible light spectrum. Here are the equations for converting between different temperature scales. Pretty straightforward. Hopefully this is a review. T sub F stands for temperature in Fahrenheit, T sub C stands for temperature in Celsius, and K stands for Kelvin. Remember, Kelvin does not use degrees. Excellent. Moving on. Couple quick questions just to review the video. Which scale is more precise, Fahrenheit or Celsius, and why? What is absolute zero in degrees Fahrenheit? And then I'd like you to skim ahead in the textbook. I'm just kind of look through chapter 12 and 13 right now, and I'm curious to know how much of this material have you seen or seen before in other classes, possibly chemistry, physics before,